Digital Diagnostics. My name is Bernie Jaroslaw. I'm the marketing manager for Whitmix. Today's webinar. So I'd like to begin with a couple housekeeping items rather. First, in the upper right-hand corner of your screen, usually, you'll see a questions box. Please feel free to type in any questions you might have throughout the presentation, but our presenter will be answering those questions at the end. So just write them down and we'll get to them. And next, if you're a CDT, this webinar is approved for 1 hour of CE credit towards your recertification. You will receive an email within 1 to 2 days, and it'll tell you exactly how to obtain your credit. It involves a short test, an easy one, and so I would suggest you take notes if you can. Lastly, this webinar is being recorded, so within 24 to 48 hours, it'll be up on the Whitmix website in the webinar section. So just go to whitmix.com and you'll see it up at the very top. Click on webinars and it will be there. You can rewatch it. You can have people in your lab who haven't seen it watch it, and you can also obtain CDT credit through there. So this morning I have the pleasure of introducing Al Fillastre, who is a CDT, and he owns and operates Ceramo Arts Dental Laboratory in Lakeland, Florida. Today Al will be covering printing digital diagnostics, a few tips to make it easy. So really, Al, if you're ready, let's talk about printing digital diagnostics.
Hey, thanks, Bern. I think I'm ready. Do you hear me okay?
Yes.
Yep, perfect. Okay, cool. So, well, pretty much the title speaks for itself. Printing digital diagnostics, a few tips to make it easy. Sort of a follow-up of a previous webinar we did about, digital diagnostics and how to do that. I do want to review just a couple quick things because it's an important topic. And if you are like me, 90% of what goes in leaks out by the next day, and so it's always good to review a little bit. So really just want to highlight the fact that digital diagnostics is done using this temporary unprepared model workflow. You always need to make sure that you have it set as unsectioned, and that, make it all one bridge. Typically, it makes insertion direction easier. You only have one direction you have to set. And then with no connection, though, because we don't want that. We want to just have them touch each other. Now, I also spent some time talking about the 2D, 3D isometric dilemma, meaning that when we try to view a 3D world on a 2D stage, everything gets distorted. And so proper perspective is everything. And just hit a couple key points here. We always want to define our horizontal axis, and there's ways for doing that. And we want to be aware of some of Bonwell's numbers, which are quite good to use. That the maxillary central is 110 millimeters from the condyle, and that the maxilla slopes down at 10 degrees. This is really the information that we want to transfer into our virtual articulator in order to make sure that what we see is what we get on the screen, because it's a big waste of time and money to print diagnostics that you thought looked good, and when you get them, they don't look anything like what we thought we did, which has plagued me all through this whole digital experience until somewhat recently when I figured out why this was going on, and that's what this is all about. So suffice it to say that on any given articulator, virtual articulator, the maxilla is typically not in the right place. Apparently this is being fixed with 3Shape, but really the key is to center it vertically between the bows, and on this articulator that's about 53 or 54 millimeters from the top and the bottom, and to make sure that we have it in the right place from the condyle. So on this articulator, which is the 330 for Whitmix, I use this little notch as my reference point, this line. And if I set my maxilla back about 8 millimeters from there, it's the right distance from the condyle. And if I bring it up about 9 millimeters from this alignment plane that we see, it's also vertically in the right place. So that's a quick review of how we set it. And no matter what articulator you use, you want to do this, okay? And this 10-degree down angle, we talked a little about that, but it's a line that goes from here to about here. And if you're on that line, you're going to be good. From like where this connects the pin to just below the condyle right in this area. And if you're on that line, you're good. Anyway, once you do this once, you can save it. You can tell it to be the default placement for future cases. And so long as your maxillary cast is in the same place on the scan plate every time, it'll be in the right place on the articulator every time. So you do want to have some consistency there if you can. So anyway, So again, and as far as getting the horizontal axis, we talked about getting a proper stick bite, which really is just a stick parallel to the pupils, but not on the incised ledge. It's apical to that, so we can mount the case and scan it without getting in the way of the incised ledges, yet capturing the stick and define our horizontal. And the last thing is, once we do that, we can set this, I turn on the articulator all the time while I'm doing this, okay? And this then becomes a line, this little disc that we use to align the maxilla. And with this blue ball in the middle of the pin, we're looking straight on. And unfortunately, there's no icons to square the articulator in Dental Designer like there is in Appliance Designer. If you've noticed in Appliance Designer, we have additional icons over here on the right that actually center the articulator for us in both a front view and a side view and a top view, but it's not in Dental Designer yet. So you have to actually manipulate this to be centered so that you're actually looking at the case straight. Because if you're not, then this is the kinds of things that happen. Here's a little arrangement that's square, and we did talk about this last time, but I got some questions about it because people didn't really see or understand what I was saying. And so this is square, right? We have a nice horizontal plane and we have a vertical midline perpendicular to that. That's what we want to see. But if we're not looking at it square, it's not right. If we're looking from slightly above, suddenly the incisors look longer. Look at the difference in the space at the tips of the cuspids. It looks like these are way too long. So we want to shorten these, but it's not true. It's kind of fake. And if we're looking from slightly below up, it looks too short. Doesn't affect the direction of the midline, though, if we're looking straight on with just a little bit from above, a little bit from below, but it makes a huge difference what we see on the screen. And again, if we're looking from the right slightly or from the left slightly, this then does start to distort the appearance of the direction of the midline, which if we weren't aware, we weren't looking square and we tried to fix this, we'd end up with a slanted midline in the final case. Okay, and this doesn't affect the apparent length if we're just looking from the left or from the right slightly. Again, all this just so you be sure and square your articulator and take the time to set this stuff up before you start doing interior diagnostics and smile design, because you won't get back what you saw on the screen. And I know you've all been through that because I have, you know. Anyway, so to start this, whenever you're going to do a diagnostic case, it's very important that when you're scanning your models that you trim them where you want the base of the model to be when you actually print it. You can't do that in Model Builder, and I'll show you why later. So when you've got a case that's going to be diagnostics, make sure you do a really good job of trimming this, getting it square. Take your time, get it right. Okay, and in this particular case, we're going to be printing the opposing as well. And so I wanted to make sure I trimmed these really nice because that will be the thickness of my model, plus a millimeter when I print it. So step one, be careful with that. And because you can always go back and rescan and retrim, but that's time consuming and it's just a pain in the neck. Okay, so quickly then, here's an anterior smile design case, looking at the occlusion. And again, once we have it properly aligned on the articulator, we can adjust this. Just a little review, we see a little working interference here, which would mean we would want to increase the angle of this cuspid to lift that off and eliminate that. This is basic smile design. We got rid of it in this case. We got some nice protrusion on our centrals. You can group that with your laterals if you like. Nonetheless, the main point aside from that is that when we do this, don't cut your teeth to the model. Always leave them uncut. Don't cut to the tissue, and there's a couple of reasons for this. One is it'll make your final model a little bit better because when we copy and append modeling to a scanned model, 3Shape does not make it one entity. It combines the two, but you got two separate STLs going on. And when you cut to the model, you can leave a gap under the tissue, and it can create a small issue when you're trying to print a solid model. Again, and also when we come back to reuse this modeling, when we finally get the actual case with the preps, if you haven't cut these back and they're bulbous under here like our library tooth, you'll get a better adaptation to your margins when you actually get the die, scan those, and reuse this modeling. So there's a couple of reasons to not cut to the tissue. And also sometimes it can take some time. Okay, so once we have our design like we want, for our diagnostics. Now we need to go and take the steps to produce the STL of the combination of the modeling with the model, the scan pre-op, and then ultimately print it. So step one is to close your case and go copy, and append. And what this does is just append your diagnostics to the scanned arch, to the scanned model, creating one entity, but it's actually these two STL put together. They're not actually joined by 3Shape. If you pulled a 2D cross section, you could see the little gap between them. So as soon as we do a copy and append, it automatically takes us to the dental manager screen like this. And a couple things here will help make this process simpler and cleaner and neater. Okay, number one, clear out all your old, it'll keep all this from your previously defined case. Clear that all out and get rid of it. All right, and just clean the slate. Then make sure we go up here and change this to a digital impression, because that's the only way to invoke the model builder options in your drop-down menu, so you can actually access model builder with this. Eliminate the antagonist, okay, because unless for some reason you want to print that in this particular case. And if that's true, then you can leave it and print both, but typically we're printing just the one, so I like to eliminate the antagonist and make that none. And quite often, if you have a pre-prep scan, just eliminate that. It clears it out and just keeps everything cleaner and neater within 3Shape. So then we need to make sure that we define our arch. So I clicked on one tooth to clear it all, leave it clicked, and now I can come down here, click model, and set these options properly. It will always default with dies. Okay, we don't want dies. So make sure that you uncheck that and just leave this one, which is unsectioned. This is the only one that should be checked. All right, sometimes these icons can be a little confusing as to what they do. Just all we want is an unsectioned model, nothing else checked. And then we're golden as far as what we need to do this. Now, if you did want to have this antagonist and you did want to print that, you'd have to hit one of these teeth and set it up exactly the same way with your model material and as an unsectioned model. So it'll always ask you, do you want to rescan? No, you don't need to do that. And one thing I want to go through here is just to show you a little background information on 3Shape that can help you out down the road. It's like how 3Shape actually handles these kinds of cases in terms of file names, okay? And so if we go into the case and explore and go into scans, and then from there go into the arch, which in this case is upper, we're going to see when we set this as a digital case, it will automatically produce this file, and this is what Model Builder looks for. Okay, and anytime in 3Shape that we're going to, let's say, copy in our own scan of something else, let's say we want to print something different for whatever reason, if I copy it in here and name it this will be the STL that Model Builder will grab. But naming is everything in 3Shape, okay? It looks for it. If you don't have it right, it won't find it and you get an error, okay? So, you know, this stands for Model Builder. So this is the STL that we copy and appended, but the name is critical. This is the MB is caps, then there's a space, then that's caps, okay? Then there's a space, and then scan is all lowercase. Okay, it's got to be written this way for 3Shape to see it. So you could set a case up and go, you could copy in the lower STL, name it this in the upper subfolder, and it will find it and model build it. Okay, so naming is everything, like I said, in 3Shape. And if you're not really familiar with manipulating 3Shape at the file level and copying and pasting files from different cases to get what you want when you're trying to combine things and put implants with diagnostics and do different things, that's a skill you really should develop. It'll help you a lot down the road. And again, you know, the MB preparation scan is that file, and the raw preparation scan is exactly the same thing. It's just the name that differentiates how 3Shape chooses to use it. All right, so once we've done our copy and append, we've renamed it, we've done our things, we've set it up as a digital impression, we've set it up with no antagonist and no pre-prep scan, and set it up as an unsectioned model. We'll see this. All we have to do, pardon me, All we have to do is right click on it and the build model icon or the build model option will be there. If it's not there, there's a problem. It could be in the file naming. If it's not there, go look, explore, and make sure your model is named MB space preparation space scan. And then it will find it and give you that option. And again, we don't cut these back. These teeth, these 2 bicuspids, I didn't use. I just put them below, I put them inside the model so they were hidden and they will just disappear. So you can do that too. I will sometimes set a case up with more teeth than because maybe I'm not sure when I start in, am I going to do the buys? Maybe, let's check it both ways. I can expose them or unexpose them, but anything that's inside the model will not get considered in the model builder. So as you can see, we do have this cutoff nice for a small base, economical. I don't like to print any more than I have to because it's not cheap. And the taller, the more time it takes as well. So this, we took time in our scan to make sure we trimmed the model nice, hence we get this in Model Builder. And this step of setting the occlusal plane is absolutely critical. All right, and you really need to do this. It will, for whatever reason, always come in reversed. Now, spinning this around doesn't affect the actual model, but it affects orientation. So I always spin this around to get it somewhat straight. Okay, and then you really want to look at this. You need to get this plane parallel to the base of your model. Otherwise, you'll get one side of the model really thick and one side really thin because your base will end up parallel on the bottom to wherever you have this plane. So I'll look from the side and get it, parallel to the bottom of the model. Then move it up to get it above the occlusal plane. And again, you have to have at least, I think, 10 or 15 millimeters here in order to be able to keep the base thin. Okay, if you have this down, it'll thicken the base to always stay 15 millimeters away from this plane. So make sure you raise that plane enough, and then look from the front and get it parallel to the base from the front. Okay, so that this occlusal plane is parallel to what we want the base of the model to be. The other problem that we have here, though, is the occlusal direction. Okay, down here there's an option to flip it. Okay, if you don't, you won't get a model, you just get a line of gray, and if that happens to you, it's because you didn't flip the occlusal direction, which is almost always wrong, except in a lower, it's always right. It always points this way on an upper. So you just flip it, it'll do that, okay? As long as you see the arrow pointing towards your teeth, you're golden. All right, and we're gonna just next on through this. And again, on this screen, I will typically put the patient name here so it appears on the model. And pardon me, just for identification purposes, make sure that you turn your articulator off because you don't want to print the block back there. It will print the block. And then you can move the patient name anywhere you want. Just grab it and move it, okay, and put it somewhere out of the way just so it's marked and just so you have an identifier on the model. And a patient name is much better than a case number, unless you don't want to use patient names because of HIPAA law. So that's your particular preference. Now we can go into the file menu up here, okay, and modify some of our options. I can change the surface thickness. I've gotten to where I drop this to 1 millimeter to save material, because in a case like this, it doesn't really make any difference in the strength or the integrity of the model. You can change the base thickness if you like to make this base thinner. It doesn't like going below 1 millimeter. You can try, but I'll get some errors sometimes in the making of the model if I go below 1 millimeter. But I'll typically do that and then end up with a base that's kind of thin or as thin as I can get it, again, to save the maximum amount of material. Now, if you don't like this lip, which I'm not a huge fan of, and it will do that automatically, and you try to trim this off in the final sculpt stage, okay, we can go in here and pick this plane and we can trim this down, okay, like that, and make it look really good, make it even a little bit thinner, save a little bit more material. But if you do that when you get to the end, it will not hollow your models, even though you have it set to hollow your model. You have a wall thickness. And so in order to have hollow models, now this is up to you. If you don't care about the extra material for having a solid model, fine. I like hollow models, so if you see that and you cut it, you go back and then undo that step, right? Undo that cut, put that back, and then when you proceed through, but it does give you this, and then when you proceed through, you will have a hollow model, which will save you a lot more material than you saved by cutting that little lip off. Again, it's just part of the way 3Shape does their model building. Now, once I finish and I generate my STLs and I go in and explore, I will typically change the name of the STL to the patient's name and the doctor name so that when I file them after I print it, if I ever want to go back, I can find it easy rather than looking for a number and trying to figure out what number was this patient's case. So I'm a big one for just renaming things that make more sense. Okay. Just something that I do. And again, here's the STL that was created. And so we drag and drop that over to our printer computer, if it's a different computer, and then start the printing process. Or, which now this is all based around the Asiga, which is a spectacular printer. And I really like that it's real simple as we start. The first thing we do is get a dialog. We define what material we want and how thick we want the layers. And if I'm doing a model, I'll take it up 125, maybe 150. I would try, see what gives you a surface you think is okay. Accuracy will be good either way, but the thicker your layer thickness, the more stair-stepping you'll get and more of those little lines on the surfaces that you will see, okay? So once we decide what layer thickness we want, we go in and we with this icon here to add an STL, we pick what we want, okay? We tell it to open it, and it'll place it on the build plate. And if that's good, it's good. Typically, it places it quite nice. If I've got more than one, I may do some manipulation. But in this case, we're just going to go straight to the pinning, which is this icon here. And I got a couple of tips on how to set this screen up to give you a better automatic pinning of your models. Just by playing around, found out by putting support spacing at 10 millimeters here. And now this is controversial. I like to put my models on pins. Okay, so they're up off the build plate. And this does two things really for me. It does one main thing. Two. It makes it easier to get off the build plate because you don't have to get that, use a hammer and a chisel to get that whole base off of that build plate. It can stick fairly well. It also allows all the uncured resin that would fill the inside of a hollow model, it doesn't get trapped in there. And I'm telling you, that's a lot of resin. And if you put the drainage holes, which you can do in 3Shape, it's almost like a die pin access hole. It can put holes around the base. It doesn't look so great, and it doesn't really drain very well either. And you still end up losing a lot of resin when you clean the case off. So if you didn't want it to be up off the base, you just set that to 0 or uncheck that, take your pick, and then the model will build directly on the build plate. Again, I like to have it set up by pins. Now, one possible drawback to this is that every time you have a pin, you have a slight little dimple can be in the foil or the plastic on the bottom of your build tray, which I was told could be problematic and make a build tray prematurely go bad. I have never seen that, and that's the only way I've ever done it, is to leave it off the build plate by 2 millimeters and then just let it be supported by pins. But with these settings, with 10 millimeter spacing and 2 millimeter off the build plate, we get a really nice arrangement of pins every time. And this icon here, this to look from the top, if you click it twice, it'll flip it over. Boom, boom, really nice, and let you see how your pins are underneath. I don't even do this anymore because every time I pen a model, it comes out just like this, really nice, perfect. The software is fantastic with the Asiga. And then really we just click through some options and set this up, and then this icon sends this build to our printer. Okay, and that initiates a sequence of screens, and you pretty much next through this. You have the opportunity to change settings. You can go to fast print mode. You can do separation detect. These are fairly new features that help the printer print faster. Okay, I have had a couple little separation issues with the fast print mode. I don't really know why I haven't dug into it. This separation detect is what really makes it faster, and this has worked fantastic for us printing our models. This really just recaps all the parameters for the exposure and everything, which is built into your material file. I don't recommend ever changing any of these. This is just next through this stuff. We get to the end, and this is where we name the build with the patient name. So if we need to, we can pull back up the build down the road, and then we send it to the printer, and off it goes. And after it sends, it's going to come back. It's going to ask you if you want to view the slices. I used to like just view them all the time to make sure they were all there. Never had them not all there, so I just closed this. Okay, but if you want to view your slices, you can. Once you close it, you click the little globe icon, which really kind of indicates internet, I guess, or your network. And then you get this screen that shows you the front of your printer so you can control it from your computer, or you could go actually touch screen the printer to do this. When you hit your front panel, you choose print, next build. It'll come up with the name of your next build, or you can choose the build if you have more than one queued up in the printer, and then you continue and it shows you how long it's going to take to print this. All right, it verifies your material, and then off you go. Boom, it's building. Right now, this is one little thing that we did to our printer, and I just took a little piece of plexiglass and I cut a wedge, and I put some hinges on it, but it didn't work. Actually, it's just a piece of tape on here holding this to the side of our printer. You may ask, what is that? what is that for? Okay, well, that's partly because I'm cheap and I like to save as much of this expensive resin as I can. And so after we build, unless you're in a big hurry, we will flip this wedge up. Again, remember it's hinged or taped on here. It'll hold the lid open and allow us to sit the build plate in here. It'll stick it out, stick the bottom over to the top of it out past your lid. It'll hold it there really secure and let all that resin that's on your plate and inside your models and all over, you'll get a substantial amount dripping back in. Again, it works really well. It's safe. And then when you want to close the lid, you just flop that down and it closes, and you will save noticeable amount of resin. If you don't have time, you don't have time. I mean, but if you do, hey, we'll do this, walk away, come back in 5 minutes, and then clean it up. Just a little tip I thought I'd show you there, so that when we do start to clean, most of the resin is actually flowed off and is back in the build tray, and we've saved ourselves, hey, enough resin to probably print a couple of these. Anyway, just food for thought and a suggestion. So once we clean it, we've got our model. Hopefully the teeth are the right length and everything looks in real life like it looked on the screen when we were doing our design. And if we took the time to align everything, it will. You'll be surprised how much better your results will be. And then, depending on what you or your clients like, we typically make a putty matrix if this is going to be used for temporaries, and send that along so the doc compresses temporaries. But you can treat that any way you like. Now, in this particular case, we also wanted the mock-up of this for the doctor to be able to actually put this on the patient's teeth at the case presentation to basically show the patient what our plans were. And I take this exactly from that initial design that I did, that I just printed the model for. But this time I do cut it and I make what I would call a mock-up, or a connected series of veneers from that same case. Well, before I do that, I don't want to mess up my model that I just made. That particular case, I'll just do a standard copy of it. Okay. And then now I talk about modified. This is just me. I like to, when I'm setting the case up in Dental Manager, I put the patient's name, last name, comma, first name on the last name field. And here on first name, I use that for notes for what this is. And it shows up nice in Dental Manager. Just an idea for how to sort of, classify or categorize your cases as to what they are. Because a lot of times I'll have diagnostics, then I'll have to print the model, then I'll have to design abutments, and then I'll have, a variety of cases of the same patient as we go through it. And then I can quickly look at Dental Manager and see which one is which by looking here, and it'll show it, right? What this is all about. We lengthen the cusp. Here we we printed it. Here we made for a PMA bridge and so on and so forth. This case had a lot of little different moving parts as we went through it and did a few different things as it evolved. At any rate, this is the one that I want to go make the mock-up for. So we make the copy. All my modeling will still be there. Okay. You do need to pay attention to setting your insertion direction so you can see the parts that you want to have print. You don't want to cut holes through them. So I'll look and try to see an even amount of lingual and facial and as much of the distals, get it as square as I can, set that direction, and then just click through it. And as you click through it, you know, the tendency is to say, oh, okay, I'm done. I'm going to cut this to the tissue right now at this stage, anatomy design stage. Do not do that, okay? It will mess you up if you cut a tissue now, okay? Don't. Leave them uncut and proceed to the next step. And the reason why is because in the next step, when we go, okay, and I just undid the cut so I could demonstrate. I want to see it like this when I move on to my finalized stage. The reason why, if you get here and then you're trying to thicken up these connections, because we want to, so it'll hold together when the doctor puts this in the patient's mouth and lets them take it home. If you're doing this and it's acting like your modeling is moving away, like you're using the minus tool when you're actually using the plus tool, and also you're going, what the heck is going on? It's because you cut it back prior to this step, and when you try to bulk these up, it doesn't work well because it's so thin underneath here because you've cut to the teeth. All right, so wait until you're done enhancing your connections in order to give it some strength once we print it, so it'll stay as one piece and be able to go to the mouth. And then at this stage, now is when you go cut it, okay? And you see here, I've got 0.07, like 70 microns seems to be a good number to give you enough space to be able to get it off and on the model well, okay, and to still leave it thick enough without making a bunch of holes in your modeling. Again, on the lingual, when this happens, there's no worries. Remember, this is to be just tried on prepped teeth, and you're going to see this. If you don't like it and you really don't care about having the occlusion proper, you can go back and thicken these areas up. Just back up, thicken them up, and then recut it. If you want to do it that way, but I'm really interested in having just a facial with no holes in it. And again, sometimes it will, because you're not doing very much of an additive case, and that's okay. In the mouth, it'll just a little bit of unprepared tooth show through, but you'll get a really nice presentation to the patient as far as what the proposal is. And I'm telling you guys, this is a service that, you know, it's worth just giving it away, because you take a patient that's on the fence about an anterior smile design case. Maybe they didn't even come into your client with that in mind, but it's very noticeable. And you do this and you deliver this to the doctor and don't even charge the patient. You know, now if the patient buys the case, yes, I would like to get paid for my diagnostics down the road. But if the patient doesn't, you know, then the doc and I both share a little bit of, you know, skin in this game. Works out really well. I think it could be a really nice value-added service to really kind of give away. And again, remember, when we're done with all this, you give the doc that makeup, he gives to the patient. They take it home and show whoever they want to show, or take it to work. They buy the case. You'll be surprised at what the percentage of acceptance goes up. But again, I will take this STL after I generate it, rename it for what it is. That's just me. I think it's a good practice to do that. And then that's what we got. And now I'm going to go print it. Now, I did this while the other model was printing. And so on this, I give, you know, a little bit finer layer thickness, 75 microns, to make it a little bit nicer surface, perhaps. That's just me. Choose it, put it on the build plate, and I tend to pin these with the facials down. Okay, I've had too many cases where I pin the incisal edges kind of wrong and I lose a corner, and it's really hard to put it back. And losing a corner on a central is not good. It doesn't take much to look bad when you're talking about anterior teeth. So I tend to run my pinning, auto pinning, with the facials facing down. And then you can come in here and with, add and remove, you can come in and change this around a little bit if you like. It tends to do quite a good job. I think overpinning, I'll take ones off maybe that are on an edge like this or something. But I find that when I take this on through and print this up like that, it's really easy to grind these little tips. They're teeny where they attach, to just grind them off instead of mess with my incisal edges, which really affects how these teeth look in the mouth when the incisal edges get messed up a little bit or corners get messed up a little bit. Okay, again, just what I do, I'll throw it out there for you. And then we name the build like before, we send the build and it goes to the printer. Now, at this point, I was in the middle of printing that model, okay, but I also have the diagnostic mock-up that I want for the same patient. I wasn't aware that he wanted that until this was already printing, or we could have done them at the same time, of course. But in SIGA, you can send a build to the printer while another build is going. No worries, you can set up a queue, and then when that build's finished, you take it off the build plate, put it back, you can then go ahead and proceed to print this. All right, so which is what we did. When that was done, we went and built this. Took 31 minutes. And another reason why you might want to pin on the facials instead of the incisal edges is height, right? The lower an object you're printing, the faster it prints. It's all layer by layer. It doesn't matter how much you have spread out across the plate, it's how high it goes. And so this also makes them print a little bit faster when you orient them this way. So anyway, we cleaned it, we took it off the build plate, stuck it on the model. They'll usually fit at 70 or 75 microns of cutback. It'll fit pretty easy. I rarely have to adjust inside, but I will always place it on the model before trimming these screws off, so I don't, because this isn't like real strong. It's strong enough, but it's not, solid. You can break these things, and sometimes they get somewhat thin. And so again, like I said, it's really easy to smooth these facials, grind them off. And unfortunately, this case is a case in progress. I never got the pictures of the actual mock-up try-in, but this is one we did not that long ago where, she came in for these 4 teeth, or these three or four teeth in the front because they were yellow. And, we saw all these occlusal plane issues and made a mock-up presentation of this lady. And she actually cried. She did. She actually cried and just couldn't, and of course bought the case. But all this work was not wasted. We just reused all this when we got the preps to the final case. That's one really nice thing about digital, as we all know. Now, trios cases are a little bit different, and it depends on which version of 3Shape you're in or what you're going to have to do, okay? On 2018 and earlier, if you get a trios case for diagnostics, you have to convert this from a digital case to an analog case. And so, because if you don't, you won't get the option to copy and append after you do your modeling, and it will make you crazy. So if you're on 2019, they fixed that, all right? But on 2018 and earlier, as soon as you get the trios case, don't do anything. Do a standard copy, okay, of that case, and then go and modify that case and change it to a model, to an analog impression, okay, change it to unsection, change it to whatever you need to change it to in order to make it a model, antagonist, and unsectioned. Okay, you can keep a pre-prep if you have one, whatever, and then just define your case as you want for the diagnostics. All right, and then would you like to rescan? You can say yes, but it won't anyway. You have to go back through the rescan and you have to import the scans, okay, into this. Pardon me, no, you have to go back through the scan in order to trim your models and get yourself set up. And again, let me back up. I always activate the virtual articulator right away before I start anything in these cases, okay, and go right to this icon to the modify the alignment icon to look at what's going on with my occlusion. And for whatever reason, this varies a lot from doctor to doctor with trios, but it's always bad. As you can see with my collision lines on over here, I have penetration of one model through the other, and this will completely screw up your occlusion. You'll end up with shy contact all the time. So you have to open your vertical, and I do this simply by opening the vertical. I don't use this optimize hardly ever. I will look at it from time to time, but usually it's between 50 and 100 microns to pretty much get these penetrations eliminated. All right. If you take a look at optimize, what it tends to want to do is twist the models a little bit. You see this little twist going on here? Okay, that, when you see that and it doesn't come straight vertical, I guarantee you your occlusion is not going to be correct. There's something about this optimized algorithm that, in my opinion, doesn't end up doing as good a job as just opening vertical until you get your penetrations eliminated. So we're going to go through, just do our modeling. We're not going to cut the pontics to gingiva. And then we're going to copy and append this. Again, that's not available. You won't see this option pre-2019. All right. So now we got to go change it back, right? In order to be able to print the model, because it's got to be digital. So now we're going to redo exactly the same procedure we did before. Okay, we're going to change this into a digital model. In this particular example, I didn't clear this out. You don't have to clear this out to make it work. It just keeps it simpler for the case. You set your printer material, you set your icons, and if you look, when I took this screenshot, I didn't have it set for unsection. This you'll know right away when you get into it, it starts asking you to define margins. If you get into Model Builder, it's asking you to define margins, it's because you have this dies icon clicked, you didn't turn it off and turn solid model on, okay? So you'll know if you miss this, in which case you just exit, come back, turn that off, turn that on, and continue. Okay, but it's really important to have this done. And I did clear this at the end. So you don't have to clear them at the beginning, just clear out your stuff. And trust me, it'll keep this much cleaner, much simpler. Now we can go to build model. Okay, and of course this came from the trio scan, right? From the mouth, and it's all raggedy. And so if we just go through and print this, we're going to get a base like this, which is raggedy, really thick, a lot of wasted material. And so we're going to want to trim this. Okay, and there it is, right? Trim preparation. Well, guess what? When you trim this and get it really nice, your tooth just disappears and you can't do this. Now, had we scanned this case and trimmed it, we would just not be able to get a hollow model. In this particular case with trios, you don't get any of your modeling, right? So you can't. If you want to trim this, you don't want that thick model, you're going to have to go back. You have to go through, reset it to scanned, so you can rescan, and when you do that, you're gonna have to load all the scans. You're gonna have to go find the original case, right, through your case numbers, dig into them, go into your scans directory, go into your lower, pull in your model, right, your raw preparation. For each step, you're gonna have to actually load. It won't auto, even though they're there, it won't load them. Then you can trim this how you want. During the scanning, you can trim excess. You can trim it any way you want to do. Okay, and then go on through and get your upper and trim that because you're going to need your occlusion. You want to go back and redesign. When you get to your actual occlusion scans, just be aware that in a trios case, there is a miscellaneous folder, and that's where your bite scans are. So you can load those as well. You don't have to scan anything, but you got to load. So raw bite scan is in there, and you can align it just like a case you scanned yourself. All right, so you have to go through the motions, but all the data is there. Just go find it and do it. And at the end, this happens all the time. Attention, not all scans are saved. It's like, what? You know, so you say, oh, well, it's probably okay. And you try to go model and you get this. The virtual model is not completed. Ugh, okay. What it is it's just, you got to go back through and rescan, okay? But all it is you don't have your annotation on the tooth. And for whatever reason, when you go back through this, it doesn't stop you. It lets you proceed, and it won't put a check mark on that step. if you catch it, you can go back and then go ahead and add the annotation back in the step. But if you don't do it, it won't work and you won't be able to proceed with the case. Okay, you have to do that. Then we're going to go, back through, and we have to just kind of click through the redesign of this to basically get our modeling onto the model. And then we can go and change this into our digital impression, clear the form, set up our model, get our proper icons checked, okay? Don't need to rescan. And then we get this option, we can go build our model. And this time when we go in, we're cut nice, okay? We got a nice thin model. Again, going back to save some material may or may not be worth it to you, all right? But if you like to do that, then you can. And again, remember, don't forget to align your occlusal plane, because if you don't get it parallel to the bottom, you're going to build this whole part up, because that's going to be parallel to your occlusal plane. Okay, so that's what happened here. So again, when we go through, we didn't want to do it that way. We want to make sure that this plane is parallel to where we trimmed all this, so we keep a nice thin model. Again, saving material. And just going to click through, right? Send the STL over to our printer, same old thing, right? Just run this print routine. I never even look twice anymore with these pins set up that way. It'll pin them really, really nice, very even around the model. And again, my reason for that is so I can drain out the liquid really easy. Makes it easier removal from the plate. Print it at, in this case, 100 microns. You can try more. Now, I changed the material. Okay, I don't know if you noticed that, but what I did was I went through and I changed my thickness from 75 to 100 after I pinned it. Okay, you can go to build properties up here and you can change anything you want after you pin. Well, if you do, it could change the way it'll print. The pins are based on slice thickness, the material, all kinds of different things. So you'll get this warning that, okay, you change things, it may affect the pinning. So you can discard your pins. I usually do because I really don't know and I don't want to misprint, and then repin it. Okay, if you ever see that, just discard your pins, repin. It's 2 clicks and you're done. All right. And then you go through the process, click, 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 name your build, send your build to the printer, then go print it. Okay. Front panel, next print. This is same old, same old. It just becomes routine through all this. 34-minute to print, and then it's building, and that, as they say, is that. Okay, guys. I mean, pretty much, we covered most everything. If you have any questions, hey, I'll be here to answer. And I guess I'll turn it back over to you, Bernie, because we are done.
Okay, great job, Al, as always. Thank you very much. I have no questions on the screen yet, so I'm going to assume that some of you were waiting till the end to write them in, so we'll give you a moment or two to do that. And while we're waiting, I'm going to just reiterate that this webinar was indeed recorded, and it will be up on the whitmix.com website. If you go to our homepage, it's right at the top. Just click on webinar and you will see it in about, usually it takes about a day, could be up to 2 days. And same time frame for CDTs. Those of you who are CDTs will, and through the same emails, will receive a notification on how to get the CDT points. It'll be worth 1 hour towards scientific credit. That will be sent out within, I don't know, approximately a day or so. And what you'll have to do is take a very quick test. It's a true or false test. I will tell you, it's as long as you were listening, it's going to be an easy one for you. And we will, once you do that, you submit it, and we will send you your a certificate, basically, which you'll send in to the NBC. Okay, here's the first question. Will Al be presenting in Chicago this February? And if so, any idea of what topics he may cover? Hope so. So Al, in fact, in the plans. Al will be speaking for us at Chicago at Lab Day Chicago in February. And Al, what was the topic that you chose?
That's a really good question, Bernie. I know the topic I'd like to do, and
I think we did choose it. I just can't remember exactly what we.
Well, it's pretty much to take what we did at the digital forum and enhance it a little bit, but really, more into this exact arena with diagnostics, the digital, the articulation, all about how to control all these parameters when we're using a digital design, and how to keep from having a disconnect between what we're seeing on the screen and what we get in our hands. And but it's going to be combining a lot of the little webinars and programs that we've done and bring all that information into one really useful package for really mastering digital design. It's going to be really good, actually. I'm excited about it.
Excellent. I look forward to that. And Kent, I know you do too. I, amazingly enough, have no more questions. That's a little unusual for when Al presents for us, but hey, it makes it easier on him, I guess. You guys were, thank you for joining us. We had a pretty large crowd today, and I wanted to thank you and invite you back to another WITMIX webinar. We have them every other Tuesday. The regulatory one next Tuesday. So tune in next Tuesday. I think that's the 20, not next Tuesday, I apologize, 2 weeks from today. It's every other Tuesday, and that will be the 29th of October, and it will be at 11 Eastern Standard Time. Let's see, great presentation as always. Thanks to WITMIX, and thank you, Al.
All right. One comment, while everybody's still here, and that is, look, always, and nobody ever takes advantage of this, say, hey, if you got a topic you'd like us to do or go over, or to get a more detail, like some area of a presentation we've done, and hey, I'd like more information on this or on that, you should let us know. You should, drop Bernie or me an email and say, hey, is there any way you could cover this particular topic? And the answer is probably yeah. And sometimes we're just looking for good ideas for topics to present. So if you have some, please share. Let us know.
Absolutely. That's a very good comment. All right. Oops. This isn't a question, it's a comment. Were there any insects, eagles, whales, or others harmed in the making of this webinar?
There were not. But look, since you brought it up, I got to tell you, this picture right here, come on, guys. Spectacular, right? I mean, it was like this giant butterfly landed. This is called a coral tree. It flowers all year long. It's beautiful. And this tiger swallowtail landed on that with the sun on him, and behind it was just some hedges. They were in the shadows, so it came up black. And this is unretouched, full-blown, straight out of the camera photo of this butterfly. Come on, that is amazing. Sheer luck that I got this.
Pretty. All right, well, thank you all again. We appreciate it. Looking forward to see you or seeing your name at a future WITMIX webinar. Thanks, Al.
Yeah, look us up in Chicago. It's going to be spectacular, I promise.
Okay. Bye-bye.
Okay. All right, man.